Hey folks, this is a video that deals with our symmetry tests. We are in the section that talks about the graphs of the basic functions as well as symmetry. I'd like for you to go towards the end of the notes after the library of functions, after the discussion on symmetry. And I'd like to take a look at the symmetry tests that we can run on a function. So the first thing is that if we're looking at even and odd functions, how do we know which one's which? We know that if we are dealing with a graph, it's easy to find out. But if I'm just looking at an equation, how do I find that? So the first thing I would like for us to look at is we're going to compare these two right here. If f of x and f of negative x are the same thing, then we will know that this is going to be an even function. We've already learned that an even function has symmetry with respect to the y-axis. If that doesn't occur, the second test that we're going to run is we're going to look at f of negative x, and we want to compare that to the negative f of x, or the opposite of f of x. If those two are equal to each other, then I know that this is an odd function, which we know means that it has symmetry with respect to the origin. So I'd like to run a couple of examples and to take a look at these tests. So the first one that I'd like to look at is example number 8. So the test that we will run first is going to be looking at the original equation which has been given to us, and we want to compare that to f of negative x. So what we're going to do is plug in a negative x for every single x that we see. So this x is going to be replaced with a negative x. This x is going to be replaced with a negative x. And this x will also be replaced with a negative x. So what will that look like? So you can see here that every single x that I circled a moment ago has been replaced with a negative x. Now all I need to do is simplify and compare it to the original like my test says. So that first term, we'll notice that I have a total of 6 negatives. There's 5 for the inside of the parentheses, 1 on the outside, making a total of 6. 6 negatives makes a positive. For the second term, I only have 3 negatives in the term, so that's going to be negative. And for my last term, 2 negatives in the term, making a positive. So once I simplify that, I have this statement. Now, if you'll take that statement and you'll compare it to the original, because that's what our test says to do. The test says that we should take the original and compare it to f of negative x. If they're equal to each other, this is an even function. So when you compare these two, is the original the same thing as f of negative x? And you say, no, they're different. So not even, therefore I need to keep running my test. So what's my second test? My second test says take f of negative x and compare it to the negative of the original. So we have the negative original. This one's very easy. All you have to do is copy down the original, put it in a group, put a parentheses around it, and a negative out front. So you see here I have my original is inside of the group, and then I have my negative out front. Distribute your negative, and you will get this statement right here. Once you have that statement, compare that. Again, take a look at your test. Compare the negative original to f of negative x. Are they the same thing? So here's f of negative x. Here's the negative original. We see that they are the same thing. Since they're the same thing, then yes, this is an odd function. If you take a look down at example number 10, I'm going to go through this one a little bit more quickly. So again, we take our first test, which says to take the original and compare that to f of negative x. So we're going to find f of negative x. Take all of your x's out, replace them with a negative x. My first term has a total of 5 negatives. 5 negatives makes a negative. My second term has a total of 2 negatives, which is positive. My last term is just negative 2. You take a look at that compared to the original, you'll notice that these two are identical to each other. And since they're identical, I don't need to run any further tests. I have my answer, it's an even function. But please be careful. Did you notice the directions? I didn't point them out to you, but the directions don't ask you about even, odd, or neither. The directions in this case ask you about your symmetry, y-axis symmetry, origin, or neither. So since it's an even function, which is a true statement, we know then that it has y-axis symmetry. So the answer to that then would be that we have y-axis symmetry.